Hello, everyone. My name is David Talby, and I'm very happy to be here today to talk to you about state-of-the-art natural language processing on Apache Ray. Our talk is going to cover three parts. First, we're going to talk about the Spark NLP library, which is the library underneath the Ray-based library that I'm going to show you, so that you understand the power, scalability, and range of NLP models at your disposal here. Then we're going to talk about the NLU library and show you some code examples, just how you can get quite a few NLP tasks done with one line of code. And then we're going to talk specifically about some of the Ray optimizations that we've put into it. So Spark NLP is the NLP library for Apache Spark. It's been around for about 3 years now and has become quite popular. It has three main design goals, which is to provide the open source community with state-of-the-art accuracy, speed, and scalability. The library gained popularity because it started very close to the kind of deep learning revolution in NLP. And it was the first to productize and give kind of really production-grade, scalable, trainable versions of some of the new state-of-the-art deep learning research. The second thing that really worked well for the library is the fact that it's the only open source NLP library that's natively scalable and can use any Spark cluster. So what you have is Apache license completely free Python, Java, and Scala libraries, over 200 pre-trained models and pipelines, and a very frequent release cycle. We're just about 3 years now of releasing software at least every 2 weeks. Early last year, was the first time that Spark NLP was recognized as the most popular NLP library in the enterprise. And since then, 2 more surveys in 2020 have kind of confirmed it from other sources that, other than the research community, when practitioners want to take NLP libraries and use them in real companies, real projects, they largely choose Spark NLP. And there's a range kind of Wikipedia, other sources that confirm that and talk about why the library has been adopted the way it is. Spark NLP has also won several nice awards. Some of them focus more, like the AI Excellence Award, on really taking really very new state-of-the-art research and making it available in real dependable production-grade systems for the global community. Some of them focused really more on accuracy and some of the accuracy benchmarks that the library has been able to provide today. In terms of accuracy, state-of-the-art is not a marketing term, is an academic term. And state-of-the-art really means the following: look at all the academic papers that are peer-reviewed and validated that have been published in your space. Look at the public benchmarks they've been tested against. What is the best really discovered algorithm today on specific benchmarks that defines the state of the art. In NLP, in the past really 2-3 years, the state of the art for very common benchmarks usually only holds for a few weeks until someone comes and says that they can do better. So when you say that you deliver state of the art accuracy, it really means that you keep implementing and re-implementing new algorithms and new results. And you can see here, this is one benchmark for almost a year ago. But you can see over the past few months, Spark NLP 2.4, we basically re-implemented name entity recognition, OCR, and different types of matching algorithms. In Spark NLP 2.5, we've re-implemented spell checking to have a deep learning-based contextual spell checker, and we've also re-implemented sentiment analysis. So a lot of the work makes sure that we keep you and we keep the community at the top of the line accuracy, which means that we follow the papers, we try to reproduce them, and when something actually improves accuracy, we make it available. Other than accuracy, one other thing that Spark NLP is very well known for is the ability to actually leverage a cluster. And this is an example of getting results on AWS EMR with 0 code changes. So of course, if you have a large cluster, yes, you'll want to optimize and play with different parameters. But even with no code changes, this is really the only NLP library that natively scales to a cluster. With scalability, we really take advantage of Spark. It automates execution planning. minimizing shuffling, minimizing memory use, caching, serialization. And there's really the one thing that Spark does really well. And we've done a lot of work with Databricks and with the Spark community to make the most of it. Of course, that scaling is not magic. And if you have complex use cases or large, very large cluster, you will want to optimize, to make sure to optimize your cluster and optimize your program. And there are kind of tools and ways to do that. Not all the algorithms scale in the same way, right? So if you're inferencing, that's something that's almost trivially parallelizable, and you'll get near linear speedup. If you're doing things that are inherently incremental, like CNNs, for example, you'll probably see less than linear speedup. The other thing we focus on a lot is speed. And speed, part of it is the algorithms, part of it is the fact that the library is written in Scala, it runs within the JVM, within the Spark process. We've done a lot of work with TensorFlow to make sure we integrate within the same process, so we minimize memory copying, we minimize serialization, we minimize communication, and there's a lot of profiling optimization that went into it. The other thing that we do is we have optimized builds for the latest and greatest, both Intel and NVIDIA chips. So the kind of standard CPU builds, there are GPU builds for NVIDIA, and there are Intel Xeon builds that are also specialized. This is one case study on AWS of training a named entity recognizer in French based on Wikipedia in French. And what we did here was really we wanted to compare just runtime. We make sure, to make it fair, we make sure we ran the same code, at least 80 epochs to achieve the same level of accuracy. So this is basically how long does it take to reach a certain level of accuracy on this hardware. In this specific case, as you see, we compared kind of 5 different hardware versions. In this specific example, this is something that we validated a few months ago. Intel actually outperformed NVIDIA, both in terms of time. It was 90% faster, and it was almost half as cheap as the Tesla P100s. I would say since then, both Intel and NVIDIA have new releases, which we are testing and validating as well. One of the things we will promise you, though, is that we will make sure that we test, we optimize, we make sure that you can make the most of the latest hardware when you use the library. In terms of what the library actually does, so it's a full end-to-end NLP library, starting with simple things like how do I split sentences, do tokenization, normalization, lemmatization, part of speech, up to more complex things like how do I do deep learning-based document classification, emotion analysis, information extraction, name entity recognition. It embeds transformers, meaning that the library itself, without external dependencies, includes things like being able to calculate, BERT, Elmo, Albert, ExcelNet, other types of transformers. It has support for 46 languages today. And actually right now it says there are 90 plus models. We're actually at over 200 already that come pre-trained with the library. So this is Spark NLP. And we said it's been around for 3 years. We keep releasing software, we keep improving it. One of the things that we wanted to improve over time, and this is where the Ray story fits in, is basically better integration with the Python ecosystem. In order to better serve the Python community, we decided to build a new library, the NLU library, that you can get today by just running pip install NLU. That basically gives you the best of both worlds. It gives you all the power of Spark NLP and everything that comes with it, but in a way that's much simpler and most importantly, better integrated with the Python ecosystem and the other tools that data scientists and data analysts use every day. So we want to make sure that almost everything you need to do, you can do with one line of code. We wanted to make sure that we natively read in data frames and we write back data frames. So if, for example, you get some text, you need to extract named entities and then you feed it into TensorFlow or PyTorch. That's a very simple thing to do. If you run sentiment analysis or language detection, and you want to get, for example, a bar chart with matplotlib of number of documents per language or number of documents per emotion, you can just do that with one line. And of course, we wanted to keep the whole thing completely open source. So everything that I'm showing you today has an Apache 2.0 license. So it's completely free, including for any commercial use. So to see what the NLU library can do, let's look at a few examples. So to install the library, all you need is pip install NLU. And then once you import NLU, you have this NLU object, and you do something like NLU.load, spell, in this case, .predict. I like peanut butter and jelly. So the load function loads a set of either models or pipelines, okay, including any embeddings and resources that are required with them. In this case, the spell name refers to a pipeline that does tokenization and then does spell checking in English. And we'll see later examples from other languages. So you do NLU.load, you load the model into memory, it returns back a pipeline, an NLP pipeline, on which you can run the predict function. One of the parameters that predict can take is a string. And in this case, it analyzes the text and you can see the results. What you get back always is a data frame. In this case, it's going to be a pandas data frame because it's just one string. And if you print the pandas data frame, say in your notebook, here's what you're going to see. You're going to see that, first of all, the sentence was tokenized, meaning we split it into words. And then you can see that we actually ran a spell checking model. And in addition to the token column that gives you the original tokenization, you also have a checked column. And you can see that the words, in this case, liked, peanut, butter, and the word jelly were actually corrected by the spell checker. Okay, so this is really all you need to do to apply spell checking to a sentence. Here's another example. In this case, what we want to do is take a sentence, calculate part of speech, and then calculate do dependency parser, right? So many dependencies between the different parts of speech in the sentence. And you can see still a one-liner, so NLU.load dep. Dep is the shortcut for dependency parsing in English. And then we do .predict, and the sentence we are looking to analyze. And you get your pandas data frame that has the token column with the tokens, as the POS column with the parts of speech. Okay, so represent is a verb, A is a determinant, grammatical is an adjective, tree is a noun, and then we can also look at the dependencies, right? So we can see basically what kind of dependency is there between words in this sentence. Going beyond kind of more the basic structural things, we can also do things like emotion detection. So NLU.load emotion, .predict I love NLU gives you the following data frame. So you have sentence embeddings because it's really just one of the, and embeddings is really kind of one of the side things that need to be calculated for emotion detection to work, because we use universal sentence embeddings by the pre-trained model here. There are 4 emotions that this pre-trained model looks for, which are fear, joy, sadness, and surprise. And in this case, as you can see, with very high confidence, this sentence qualified under the joy emotion. There are also other pre-trained models for more classic sentiment analysis. So NLU.load sentiment, .predict, I hate this guy, Sammy. You can see that we have a certain confidence. We have the sentence. So here, this is not at the token level. This is at the sentence level. And you can see that the sentiment is negative. Okay, so that's an example for sentiment analysis. Now, multiple sentiment analysis and emotion models that you can use. Another type of task that you can do, as I say, among the 200 or so models that are available, is language detection. And it's all the same format. NLU.load lang. So lang is the default model for language detection. .predict. And in this case, we don't pass one string. We pass an array with 2 strings. And as you can see in the resulting data frame, you get 2 rows, a row per sentence, as there's an ID for each sentence. So NLU is an open source text processing library and so on. The language is English with a 98.5% confidence. And NLU, est une bibliothèque de is a French language sentence with a confidence of 99.98%. Okay, so that's another thing that really, it's a one-liner. You can pass in strings, you can pass an array, or you can pass a full data frame and get the results that way. One other thing that's popular to do is really use NLP libraries to just calculate embeddings. Spark NLP comes with a whole set of them. There are embeddings for different tastes and sizes and uses. There are word embeddings, chunk embeddings, sentence embeddings, document embeddings. And the nice thing you can do with the NLU library is when you see in the example NLU.load, you don't just have one model that you're calling, but you have a string of models that are space separated. And in this case, really, we just ask the system to calculate different types of embeddings. So this is NLU.load, and then we ask, give me Bert, Elmo, Albert, ExcelNet, USE, Universal Sentence Embeddings, and GLAV embeddings. So basically, what we tell the system is load all of these 6 models for embeddings and calculate all of them on this specific sentence that we have here. And you can see in the resulting table, that's exactly what you get. You get per token, you get the embeddings, all 6 embeddings for the token, right? So you get the GLAV embeddings, Albert embedding, ExcelNet, all of those. There are several dozen embeddings that come pre-built with Spark NLP, which are basically all of the popular ones and all of the state-of-the-art ones you'd expect. One thing to know, if you're doing something like this, it's super useful if you're doing experimentation and you want to compare different embeddings, you can just calculate all of them at once, which is great. Do pay attention to how much RAM and how much memory you are using. Because the larger embeddings like BERT, ExcelNet can go into several gigabytes. So make sure you have a lot of free memory in the machine on which you are running this. So once you have embeddings, there are several other pre-trained models that just use them under the hood. One of them is fake news classifier. And in this case, we do NLU.load en.classify.fake news. And this is really the fully qualified name of the pre-trained model. So if this was French, for example, it would be fr.classify.fake news. And there's a namespace that enables this to scale. And here we predict, we want to see what happens if we ask it whether unicorns have been sighted on Mars. And what it tells us, in this case, with the confidence of 1, that this is fake, which is what you'd expect. We also get the sentence embeddings as part of the result, right, in case you want to use them further on. Another pre-trained classifier is a spam classifier that also comes pre-built as part of NLU. So NLU.load en.classify.spam, predict, please sign up for this free membership, blah, blah. And in this specific case, you get a pandas data frame. As always, you get the sentence, you get the ID, and you get the category, which is spam in this case, as well as the category confidence. And one more example, there's also a SARCASM classifier that comes pre-built. So NLU.load en.classify.sarcasm. Gotta love the teachers who give exams on the day after Halloween. Okay. Which is classified as sarcasm with 99.9985 probability. We're not going to go over all the examples, but there's quite a few of them. So over 200 right now, but really there's a 2-week release cycle. So really expect that almost every other week you should expect to see more transformers, more models, more languages that are being supported. This is all public, so you're welcome to visit github.com/johnsnowlabs/sparknlp. Then under releases there, you can see what's been released, say, for example, over the past year, and you can look at the rate of progress in terms of both the algorithms as well as the models. NLU.johnsnowlabs.com has the full documentation in terms of all the models that are available, basically all the names that you're allowed to use here. Okay, so we talked about Spark NLP and what Spark NLP is and what it gives you. And we spoke about the NLU library, which is really intended to be this kind of very simple to use, yet still just as powerful Python library. And one of the things that we wanted NLU to be is to also be able to scale and be able to really make the most of whatever hardware you have in terms of speed, in terms of memory use, in terms of ability to scale to a cluster. So with NLU, we wanted to make it very simple for people, but we really did not want to lose the advantages that Spark NLP gives you around scalability and around speed. And this is where Ray comes in. So here's how it works. NLU.load returns a pipeline. and then you can call predict on that pipeline, and you can pretty much send it everything you'd expect to be able to send in Python. So you can send a single string, you can send a list of strings, you can also directly send the pandas data frame, okay, or you can send the pandas series, right? So you can send the whole data frame, and then basically assume that the text column is the main one it needs to process. Or you can, if you can see here in an example on the right, you do NLU.load sentiment.predict text df text, and then you pick the specific column or panda series that you wanted to analyze. But there are three other things that you can send that NLU recognizes natively, which are a Spark data frame, an Apache Spark data frame, an Apache Ray data frame, or a Dask data frame. And those are three different implementations of the Pandas API, of the Pandas data frame, that are specifically intended to be able to scale, either to use effectively multi-core machines or large clusters. And our goal with NLU was to enable you to really just, if you have any of those data frames, you send them in. The code is exactly as you've seen so far, and basically just works faster and better. So let's see how this looks like in practice. So Modin is the open source project for implementing Pandas on Ray as well as Pandas on Dask. The goal of the Modin project is to enable you to use Pandas, but scale your workflows by changing just one line of code. And here's the line of code. So first of all, to install Modin on Ray, on Apache Ray, you do pip install Modin Ray, and you specify that you want the Ray implementation in contrast to the Dask implementation. And then the one line of code that you change is instead of import pandas as PD, you do import modin.pandas as PD, and that's it, you're done. Modin.pandas gives you basically the exact same data frame, almost the same data frame API that Pandas gives you. Not everything is implemented, but most of the most useful methods and functions are implemented. What it does on top of that is it automatically discovers how much memory you have, how many cores you have, and makes the most of them. You can also, if you really want to, you can configure it manually or semi-manually. But the beautiful automagical experience is when you just let it do its thing. And this is from the Modin really just GitHub repo. So this, let's say we've not run this ourselves. But here's one example of being able to fix really one of the most annoying things about Pandas, which is the fact that it just does not use multiple cores, which almost every even developer laptop has today. You use Modin, so you use really Ray, with the Pandas API on top of it. You gain the speed up either on a single machine, and you can also scale it as Ray scale to multiple machines. And the way Modin is designed and the way it's been pitched is they're optimizing for data sets between 1 megabyte and 1 terabyte. Well, basically what they're saying, look, if you're under 1 megabyte, you might as well just use Pandas because really it's so small, it just doesn't matter. If you're over a terabyte, you should probably go to something like Apache Spark, right? Or something that's really been tested on kind of really large clusters. But most of the data set, some would say are actually between those ranges, and Modin is trying to really optimize for that, that scale. So now that we know that we can actually use the NNU library with Modin using Ray, let's see one example that we haven't seen before, a very, very popular NLP use case, which is named entity recognition. So just looking at the code here, what we are looking to do is look at a sentence like Angela Merkel from Germany and the American Donald Trump don't share many opinions. Okay, the goal is to identify named entities. In this case, to identify that Angela Merkel is a person, Germany is a country, Donald Trump is a person, and American here is not, this is not a country, so usually under CoNNL, this would be kind of a miscellaneous entity, but you do want to identify. Similarly, in the second sentence, NLU is a library that solves many machine learning problems similar to Keras or TensorFlow. We want to identify NLU, Keras, and TensorFlow basically as kind of as entities. And this is useful if you're trying to do build knowledge graphs, understand really who you're talking about, be able to do anything, even things like question answering, search, in many NLP applications, name entity recognition, or NER in short, is a very fundamental task. Spark NLP, and hence the NLU library, come with a set of pre-trained NER models for quite a few languages. Here we're going to use the one in English. And here's how the code looks. So we define the data, and as you see the data, we basically just define here a table with just one column, text, and 2 rows. We create a modeling data frame. Okay, so modeling DF equals PD data frame data. Just so that you believe us, we're actually using Ray, and we also type here the actual type, so you can see that when we run the notebook, it's a modeling data frame. And then we run a one-liner, which is NLU.load NER for name entity recognition, and the default here uses, I believe, one of the smaller BERT embeddings in English, .predict mod in DF. Okay, so basically run predict on the modeling data frame natively, and there are only 3 columns that we want to get from the output, which is the original document, the list of entities, and then we show the NER column, which shows you per token how each token is classified. And you can see the result. Document, Angela Merkel from Germany and the American, and so on. That's a document. You can see the 4 entities that were extracted. So Angela Merkel, Germany, American, and Donald Trump. And you can see in the NER column the first 2 tokens. So B pair and I pair. B pair means beginning of a person entity. I pair means a continuation of a person entity. O means nothing. So Angela is the beginning of a person. Merkel is the end of a person. From is nothing. Germany is a country, so it's B location, and so on. So if you don't just want the entities, but you want token by token to understand what belongs where, you have that as well. So that's name entity recognition. And we said, still a one-liner, even though we're using here a modeling data set. And if it were a larger data set, you'll definitely benefit from the speed of using at least a multi-core machine. And to summarize, going back to the first example we looked at spell checking, this time on Ray. We look at, we define the data. So we have here, we define a modeling data frame with one series, one column, which is called text, and has, in this case, 2 rows, right? So the same thing, we define the data frame for the data here, and we run NLU.load spell.predict mod in DF. As you see, really the exact same as we did before, only that instead of sending a regular pandas data frame, or instead of just sending a string, we send the Ray data frame. And you can see the results, which is really what you get. What you will get back is a modeling data frame. And one thing that Spark NLU does is basically it returns the same type of data frame that you gave it. So if you give it pandas, you get back pandas. If you give it Ray, you get back Ray. And when you print it, here's what you get. So you can see that we have the token column, which has the original tokens, but then we also have the checked columns. So you can see that I like peanut butter and jelly, actually the words like peanut butter and the word jelly were corrected. And similarly, the words Sundays and the word days were also corrected by the spell checking algorithm. Okay, so as you see, you get the advantages of Ray. You get the benefit, it is under the hood, but you don't need to learn in your API. And really, it's kind of a one-line change. Instead of importing pandas, you import modeling.pandas, and basically you're done. If you're interested in trying this, and we said, we build it for you, so it's free, it's for the community. We'd love you to try it. We'd love to get your feedback. To install it, pip install NLU. For the documentation, other notebooks, other examples, nlu.johnsonlabs.com. If there are any questions, please email us. There's also a very active Slack community that has, I think, several hundred people per day now asking questions and sharing tips. So if you have any issue, there are people who will be able to help you same day. Personally, I'd love to hear from you. If you have ideas, if you have questions, if things are not working as you'd expected, or just to share the project you're working. Please feel free to contact me, email, Twitter, LinkedIn. I'm always curious to know what people are doing. Thank you very much for listening, and best of luck with your natural language processing projects.